Alrighty, so tonight's talk, integrating AWS with Salesforce. As you'll discover shortly, not all of AWS, it's huge. So I'm going to walk through a use case that I've had with 2 or 3 of my customers on solving a problem by taking things off platform and sticking them into AWS. But firstly, the obligatory who. So Rob Cowell, as you can see, because you're all able to read, predominantly a dev, occasionally an architect. I find increasingly these days the lines are a little bit blurred. I'm a freelance consultant, which basically means I have lots of opinions and get paid for them. But the most important thing, and this is what I was saying to Amnon here, I'm not infallible. This is a solution, not the solution. I suspect that there may be some folk in this group that have done a lot more AWS than I have. And hopefully, we've got some great suggestions on improvements and tweaks. I know there are issues, I know there are gaps, and I think in the spirit of kind of sharing that we do with Salesforce, I'm happy to sort of take on suggestions and have you thought about. So that said, no, it's not all of AWS. This screenshot, you can't read that text. There is so much of AWS services now that I couldn't actually get a screenshot that was legible anymore. Which kind of gives you an indication of the breadth of services and tools and various useful bits and bobs that AWS does these days. There is a lot to it. We're not going to touch the majority of that. We're only going to touch on 2 or 3 little pieces of that. So what are the pieces that we're going to touch on? Storage. Storage is a big problem for a lot of my clients. This screenshot here, showing the percentage used of over 100%. I don't quite know how the maths works on that one. This is a real screenshot from one of my clients. They are using 141% of their data storage, 170% of their file storage. This is a production Salesforce instance, not sustainable. How Salesforce haven't just slapped them down yet, I do not know. There's no one from Salesforce here that I'm aware of. But yeah, we desperately need to solve this problem. Today we're going to pick on the file storage. We'll tackle data storage in another time. But to give you an idea of the types of clients that I've got that are hitting this problem, I've got 2 clients that are using Salesforce Field Service. So they've got guys out in the field doing building surveys, fire safety inspections, this type of work. So their guys in the field are taking pictures of problems. There's an obstruction in front of this fire door. Here's some asbestos. Whatever the types of problems they've got are. So it's a very image-heavy business. And then my other client is an e-commerce client. So they're like a marketplace for buying and selling products. So what will happen is they also act as an intermediary. So if you've got a particular type of thing that you want to sell, that these people deal with, you can upload images of your product that you want to sell. So again, a very image-centric business model. So they're all in the same boat, and they're all now using my potential solution. So that solution, at a very high level, is let's get the images out of Salesforce. Let's go and stick them in Amazon S3. Amazon S3 is a file storage solution. You pay for what you use to an extent of both storage and transfer, which we'll talk about in a bit. But it's a hell of a lot cheaper than buying more storage for Salesforce. Sorry, Salesforce, but you're not the cheapest game in town when it comes to storing files. But in their defense, Salesforce isn't really designed for that. Salesforce is a CRM, as we know, and a platform for developing things. It's not somewhere just to dump all of your files. If you want that, you've got S3, you've got Dropbox, you've got Box, you've got SharePoint, whatever your weapon of choice is. For this particular thing, because of the various services that AWS offers, we went with AWS because we can do things with it. In terms of doing those things, the processing, we've got image cropping, we've got image rotation. So a lot of the time, folks in the field will be using their phones to take pictures. Is it portrait? Is it landscape? I had the client say, well, we've got the images coming to Salesforce, but they're the wrong way around. Resizing them, so getting some decent thumbnails that we can use on page layouts, lightning components, reports, etc. And all of this type of sort of image processing stuff we're doing with an AWS Lambda which I'll talk about shortly. And then finally, the integration bit. How do we actually hook it up? How do we get Salesforce to do the handoff and then surface that content back into Salesforce? So what we do, we use AWS CloudFormation. Now, CloudFormation is a fantastic little tool. It allows you to define a stack of all the other AWS bits and pieces and design to work together. You can just say, I want one of those. Here's a few parameters. Go build all this entire cloud-based server stack for me. We're not going to cover all of the pieces on here, but some of the more important ones. CloudFront is our load balancer on the front, so that we're not sort of pummeling these services with too much traffic. Although in these use cases, generally, we're not hitting anywhere near the sort of scale that Amazon's capable of doing. The API gateway is basically, our route in the front door. Lambda is where we do the processing. We've got a couple of optionals here. Secrets Manager, if you want even more security layered on the top of that. And Amazon Recognition, which is your object detection, face detection, that type of stuff. So if you can sort of remember when Salesforce were very keen on their Einstein Vision product, similar kind of thing. It's a little quiet on that front these days, but it's the same kind of approach. And then obviously our S3. Now we're actually using S3 for a couple of purposes here. One is obviously to store the images, but also storing our log files as well. It's a great place to drop all our log files so that we can review those later. Now this architecture is actually one of AWS's reference architectures. This was built by AWS as a sample of how you solve the image handling problem. You can go and pick up that information at that link. The links will be provided, the slides will be shared. So if you can't see it all the way at the back there, don't panic. But you can basically go to that, read all about it, find out how they built it, click a little magic button and say, deploy this for me. I want one, which is awesome. So, S3. S3 storage is called buckets, hence the picture. It's the second best bucket money can buy. Okay, you can't beat a bit of KFC. But S3 buckets as a storage mechanism is cheap. Okay, the costs are like fractions of a penny. It's fast, as you'd expect from AWS. They are kind of leaders in their market for a reason. Very easy to use. It has a REST API. You just throw files at it, and it generally figures things out. Space, you're never going to need to worry about space again, generally. And there's no grease. You don't get greasy fingers. You do with the chicken. So what's not to love about that? So the other part of it is AWS Lambda, not to be confused with the Lambada, which I will not demonstrate in front of a live audience. No, so Lambda is latches onto the concept of that you may have sort of seen banded around technology circles of serverless computing. It stands up, it does its job, it stands back down again. Very similar in some ways to Heroku dynos, but it's a little less persistent than they are. They are very ephemeral. It spins up, it does what you've told it to do, and it spins back down and clears itself out. So it's very small, it's very focused, and because of that, it's very scalable. And you can write those functions in a variety of languages. Again, very similar, with the exception of possibly PowerShell, of the things that you can run on Heroku. And then that, in turn, uses something called the Sharp library. And the Sharp library is a Node.js image library. And it has all sorts of bells and whistles, as you can see there. Rotate, resize, crop, mirror, transform, convert between formats, manage color depth, and all sorts of things that you're probably never going to need, to be fair, for this use case. So you throw it in some JSON with kind of the operations that you want it to do. I want it to rotate this way, resize that way, etc. You build up a little list of commands, and then it gives you a URL that will say, here's your image processed in that way. And again, because this is coming out of one of AWS's reference architectures, they've built all of that for you. All you've got to do is say, okay, pick up images from this bucket and drop them here. That's largely the configuration for that done.
Sorry,
yeah?
Are you taking questions during?
I can do.
So the Sharp library, if it's a Node.js thing, is this something that I functions if I had.
Yeah. It's not exclusive to this architect. It's an open source. I mean, there's a URL that you can go and download it. You can load it into your Node.js applications and tools. And if you have a need for image processing, that'll largely do the job. All right. So I won't bore you with the deployment of the cloud formation, but it's basically fill out a few fields, take the defaults, click, 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 done, and it starts building things out. You can't really see it too well because it's very small, but basically you've got a list of things that says, I'm building this, I've built this, I'm building this, I've built it. It does everything for you. So with the cloud formation, it's a huge JSON or collection of JSON files that just tells you how to build and configure these things. And they're designed so that everything interoperates nicely. It's fantastic. I know very little about AWS, despite appearances and what the talk's about. I just know that this works, and I've used it a few times, and it plugs into Salesforce quite nicely. What more do you want as a Salesforce developer? You don't need to learn 2 clouds unless you want to. But after all of this process and everything goes green and clean on here, you get the magic create complete. This is the name of the entire stack, Acme Demo Image Handler, and it's done. So you've built out your stack, and now you can start plugging it into Salesforce. So what do we need to do to plug it into Salesforce? So the way I've built it, and I stress I've built it because you may want to build it slightly differently. That's the joy of these things. I've created, in this example, I'm linking it to work orders, which is a fundamental object in field service in Salesforce. So I've created a related record on that called work order attached images that just stores the field information and the image information around images that we've attached to a work order. Okay. The way that we cunningly do that is once we've got our URL, we use that in a rich text field in Salesforce. The reason for that is rich text fields behind the scenes aren't actually rich text fields or rich text format like you'd expect out of a word processor. They're HTML. So you can put like an image source equals, here's my AWS image link, and you're able to render that in far more places than you'd expect. We have some custom metadata just to store the image, the AWS settings. So I generally have 3 settings in there. I have the S3 bucket name. I have the path to the image handler, or the URL to the image handler, which is basically where I feed it in for generation of thumbnails, rotating, cropping, etc. And I have a maximum image height. Okay, I only need the height because it's designed to sort of retain the proportions of an image. So I can say, okay, I don't want any images coming out or any thumbnails coming out that are higher than 200 pixels. So I know it sits nicely on a report and it's not huge and everything fits on a page and so on and so forth. I have some named credentials. So a secure way in Salesforce of connecting to APIs. I store those credentials. Salesforce out of the box has a named credential type of AWS v4 something something. But yeah, basically it knows how to speak AWS. Very easy. You put in your key, you put in your token, you tell it it's AWS, and that's largely it. It looks after itself. Now, normally, if you were using named credentials, you wouldn't need necessarily to have remote site settings as well. However, because we want to actually display the images and potentially be able to click on the image to see the full-size version, which would open a new tab and it's not going through Salesforce, we just put in a remote site setting to AWS just so that it knows that it's okay to open this URL. And then the bulk of everything else is triggers and classes. So we have a trigger when a new file is attached to an object, and that's when we kick off our trigger handlers and processing and batch jobs and all the other fun stuff. And then finally, for this particular use case of field service, we have what's called service report templates. They're a funny bugger. So they're not reports in the traditional Salesforce report sense. Internally, they're kind of built as Visualforce pages, very drag and drop. But you can't really do everything that you would be able to do with a Visualforce page. Think of it as like a managed package version of a Visualforce page that you can't really do too much with other than just drag and drop fields and maybe do a bit of a related list view. But that actually plays into our hands quite well which we'll see shortly. So, in terms of intercepting those attachments, we talked about sort of triggers and a trigger handler. And I think it's useful to talk about kind of the structure of how attachments work in Salesforce. So if we forget the traditional attachment object and look more at the sort of current flavor, which is the content document, we have the structure's kind of split out across a few different objects now. So our object will sit in a junction object in a table called content document link. And as you can imagine, it's the link between the content document and your object. Okay? Then the content document itself is almost, but not quite, a junction object as well. It will have some metadata about the document itself, some properties, but really the actual document itself goes and sits in something called content version. Okay? Because as you'd kind of hope for, there's a degree of lightweight versioning on these objects. So you could have, multiple versions of the same file, particularly if you've got things, that are evolving over time. And the content document object has a field called latest version ID, which basically points to the most recent copy of that. So it's a bit of a disjointed, split out model. But the one we really want to know about is the content document link. That's the bridge between what's been uploaded and where it's been uploaded to. So what we do from that is we walk that object model and we go and get the actual binary data out of the content version. We then construct a path to a URL path to upload that image. So the image handler that's on that CloudFormation stack that we built, it takes all the parameters, including an encoded version of the file. That's a little problematic, which we'll pick up shortly. There are, yet again, our favorite things, some platform limits around that, and I already have some ideas on how to overcome those. But basically, we encode that as a ridiculously long string, and then we kind of embed that in the request and throw it over to AWS. So the process is we get the data, we build the path, we build the work order attached image record that has all the constituent parts, and then we build those links and upload the images. That's kind of the process. We do it via a combination of platform events and batch jobs for reasons that I have orgs that have way too much going on when something happens, and I have to split it out into lots of transactions. That's more a factor of those orgs. It's not necessarily a factor of this, but I think the more asynchronous, the more spread out over multiple transactions you can make this, the more but the more within governor limits it tends to sit. Sure.
Two parts to this question.
Okay.
First part, how long did it take you to actually learn the content data model? And number two, how many things did you smash while trying to learn the content data model?
I know that the content data model is contentious within the dev community. I know that it's not the easiest thing to get your head around. For this particular piece where I was hooking up to AWS, I already had quite a bit of familiarity with that structure. And, hand on heart, honestly, I didn't have a lot of challenges with that side of the fence. Most of the challenges I had was around some interesting artifacts about how Salesforce handles the upload of images. So, for example, if you've got this is equally true in mobile as it is in desktop. But if you've got a record and you upload 5 attachments to it, now you'd expect, what we've all been taught about triggers and bulkification. Yeah, taking a list. Yeah, there'll be 5 items in it. All good. No. Because they're images and they want to make sure that there's a reasonable success. I've uploaded 5 images, 4 of them worked, kind of model. It doesn't roll back an entire transaction of 5 images. Each one is a transaction in its own right. It threw me off guard, and I had a call with Salesforce. It's doing weird stuff, and we actually went through with a sales engineer, a support engineer, and he basically just kind of proved out that actually.
Is that why you ended up going asynchronous?
Yeah. So originally I was kind of taking the standard assumption: you do something in bulk, you design it for bulk, you expect not to have a trigger firing one record at a time. But in this very small corner of Salesforce, it is doing them one at a time for reasons of how it manages rollbacks and stuff. So yeah, I didn't really smash a great deal on this one.
We've been working on this. I mean, this week we've been working on this for a long time. Always running into problems with the content data model, especially when you start doing notes, content notes.
Yeah, I haven't done those. This is literally just image attachments. This is and the other use case, I say, is in a communities model, sorry, it's not communities. It's a website that's pushing stuff across to Salesforce. But again, it's all like JPEGs and PNGs coming up. I'm actually screen on those file types. I don't give a shit about all the other stuff that's attached to stuff. I've done some data modeling on the orgs, and it's the lion's share of attachments and storage usage that we're burning through. We saw 170%. It's images, and big images as well. Your modern mobile phone is taking like multi-megapixel images with like 24-bit plus color depth. It's like no one needs a 12-megabit image of these things. Yeah. That I don't know. I suspect it might do, because it's still storing the binary blob within the system. So I suspect it probably does. And that's got me worried now. I'll add that to the list of things to worry about that we can improve this on. So we talked about field service. How do we use those images? So if we kind of cast our mind back a little bit we talked about sort of surfacing those in RTF fields, rich text fields. Okay. The reason for that is because it's HTML. I can't have an image object and just drop that onto a report, but I can drop RTF fields on there. So what I do is, for the service report, I have a related list. Right, so imagine this is a Visualforce page, because effectively they are. I have a related list of the work order attached images, and the only field I care about is the image RTF. Okay, that's the one that contains the image. Now, what I do when I'm constructing that, it's HTML. I can put in text before that. I can put in, a nice little box around it. I can put a label on it based on like the file name or description, or whatever other field attributes are available to me. And I can put that nice little contained area, and then I can go bosh, bosh, bosh. It's a list, okay? Because we're using the thumbnail version of it, they fit quite nicely on a list. So I can just, and I'll show you some examples of it shortly. And it becomes very easy. The constraints that the clients were under about, how can we get all our images on service report? There's nothing out the box that I've seen, and I'm happy to stand corrected from the field service folks that might be lurking in the audience. Barry's not here, so I'm fairly safe. But yeah, you can render HTML, so why not just take advantage of that? And again, very small, but I had to kind of fit things in. So on the left-hand side here, we've got the page view. It's the record view. And you can see here, we're just spitting out an RTF field. I've literally got nothing in there except the image. Some of the key fields that you can't see from way back there, but I'll point out, we have the original image URL. So the AWS stack that we've built kind of has two key features. We have the image that we've uploaded, and then we have the resized image that we come back with, okay? And I'll explain an important distinction on those in just a sec. So we have the original image URL, and we have the resized image URL. Then we have the description, which generally I just default to the file name. Top tip, okay? You could have two records that both upload a file called image1.jpg. Stick a record ID and an underscore on the front, and then you'll be able to separate. Otherwise, every time someone uploads a record to record one called image1, it'll overwrite in AWS the image1 from another record. Yeah, just keep the file names unique, folks. It saves you much of the smashing that Mike talked about. And then I just preserve the content version ID that was originally updated. Now, I said I'd come back to talk about the resized image URL. Here's where the magic happens. It's on demand. It never stores the thumbnail image. Okay? Every time you click on that URL, it very quickly runs that Lambda function on the original image and says, just run this operation on this file and give me the result. Okay? So you already, on S3, you've reduced your storage because you're not saving the same image twice. Admittedly, thumbnails don't take up a huge amount of space, but why create more headaches? So it's an on-demand thing. Again, you can't really see it from here, but it's calling something.cloudfront.net. So we talked about CloudFront on AWS being their sort of network load balancer. And then it throws a whole bunch of encoded string at it, which again is an encoded version of where am I getting this image from and what operations to run on it. So it's a little JSON string we built with all the parameters, then we base64 encode it, and then we stick it on it, so on and so forth. But the point is that, as I say, it's a point in time rendering of that image. AWS Lambda is fast enough, and the Sharp image library, to be able to do that. So what you're seeing here on this image is actually the rendered version of this. Okay, point in time, as they request it, this is the image that you're going to get. Okay, and then on the service report we talked about, we can output PDFs. PDFs, says it all. Sorry? Well, to an extent. I mean, the Visualforce uses a PDF rendering library that's based on an old Java library from about 2002, 2003. I mean, it's woefully outdated. But, we know the limitations. I've worked with it long enough that I know what it can and can't do. We can render HTML. So we've just, again, literally lifted that RTF field, which is basically an image source equals, there's our image, and we drop that in there, and we have a nice little report. And the client's happy because they've got images on their reports that they can send out to their clients. Everybody wins. Or do they? There are issues. Now, I know, that there are smarter folks in this room than me, and I know that there are challenges. So we have a governor limit issue still. The maximum potential image size is 15 megabytes. There are various factors, mostly because heap size, when we're trying to build and encode that encoded URL, that's generally the main challenge that's hitting us. And if we skip ahead to the other side, to get round that size limit, potentially we could actually we could send a message to the API saying, go and fetch this image, and then you're not necessarily subject to that because all the construction of that URL and the building of the links is done on the AWS side, where we don't have governor limits per se. I mean, there are limits, but they're far more generous than Salesforce's ones. The other challenge I've got, and this is an architectural failing on my part, hands up. I've split out the generation of the links and the uploading of the files into two separate processes. Problem with that, we can construct a link and we can say, okay, this is the algorithm, this is how it encodes, this is what the resulting link would be. We go to do the upload fails, and then we've got a link that doesn't actually work, and you get the little broken image icon. It's rare, but it's still happening. I'm still working on that one. And again, I need to kind of work out my order of execution perhaps a little better on that. One thing that I do is I always make sure that AWS gives me a success message back. So we can see here, we move on later to deletion handling. So once we know it's definitely working in AWS, then we can delete the Salesforce original. If you keep both, then you're not really saving any storage. But I only do that if I get an HTTP 200 back. So if I get a success message back, say, yep, I've got the image, we're all good to go, then I know it's reasonably safe to delete the Salesforce version of that. And then the final way that I've kind of extended it for one of my clients is I built a little Lightning component just to build them out on a list view. So this is a Lightning web component data table extended to support an image column. And then I just drop those images in there, and they can do that. One nice thing about this, and this is just a side effect of kind of how the table works. If you drag out the width of this column, the images get bigger because it's all proportional and it resizes in real time. Big QR code on the side. Again, you might not be able to see it from there, but Todd's going to share the slides and whatnot. There's a Git repository for all the triggers and classes and bits and pieces. Not the Lightning web component. I haven't got that in there yet. I'll probably update that later for you. But yeah, all the stuff that picks up from the point that the content document link trigger fires to the class that does the asynchronous handling of a work order attached image, to the S3 uploader class, etc. It's all in there. What's not in there is the named credentials, obviously, because that's pointing to my S3. But I think still it's reasonably straightforward to follow. There is an article coming out soon. It's still going through the editing process, and it's not yet officially published. But there is an article that covers this in step by step. Now go in here. Now create this named credential. Now set your bucket name in this piece of metadata. So we've done a very whistle-stop tour of what I've been up to here. But I think that between the repository and the article, when it comes out real soon now, you'll be able to replicate this 100%. It's every step spelled out for you. And that, I think, is kind of largely how I tackled that problem. Thank you very much.